So we completed the chapter 1, chapter 2 we completed, and chapter 3 we understood the bulk, the Python integration with Elasticsearch. Then we understood about the Kibana part, like what are the various part and the how to query the document and how to retrieve it. And we also saw about the plugin development in Kibana. These are the various content we saw. And the fifth important part, what we're going to see today is the searching part. Like this is like the part where the user will start to query the Elasticsearch to get some content out of it. Okay, so this is like the like already we saw like a few queries like the create, read, update, and delete. So now we will understand about how things works in Elasticsearch, the other set of APIs which makes Elasticsearch even more powerful and even stronger, like the different features we will look into it. And for our next part, we will see is the aggregation. The aggregation is for the analytics purpose. If we want to do some analytics on the data which is present in Elasticsearch, then the aggregation query is the right candidate for it. So it's supposed like out of the box solution for most of the case. And then we understand about how it affects the scoring and scoring part in Elasticsearch. These are the various part we will look into in that part. Okay.
Okay.
Just give me a
So we are
minute,
going to be.
Victoria. Yeah, just give me a minute. I just may have to
Okay.
make a call. I'll just come back. Sorry, Victoria, you were saying something. What is it?
Hello.
Yeah, I can hear you. You were saying something right before I was about to leave.
I
What is
said we
it?
should focus. I said I would really like to learn more about aggregation parts because I work a lot with analytics.
Come again. Sorry, I lost your voice.
Hold on. Hello.
Yes.
You mentioned aggregations for analytics.
So you want to say you are trying to convey that you want to more emphasize on aggregations part, right?
Yes.
Perfect. Yeah, we'll look into it. No worries on that, Victoria. We'll just jump into that. Okay. Materials, the query DSL. So hope you remember this part, right? The different features of Elasticsearch, what we explained in the first class, real time and distributed in nature. With those are the features we were understanding some time back, right? And the searching operation. So it all boils down from the mapping part, Victoria. So you remember what is a mapping, right? So what we do is we try to create the schema for a document. What is the type of it, whether it's an integer or a float or a string. So we try to define the mapping. From the mapping, it divides into two different parts. One is the analysis and the query DSL. So today we'll be looking on the query DSL part. So as I said earlier, the DSL stands for domain specific language. So like instead of SQL, they call it as a structured query language. Here they say it's something called domain specific language. You have to understand why they call it a domain specific language on the first hand. Like if you take any system, like the system like the user where they speak in their own terms. Let's say you are a healthcare specialist. Why should I expect you to know these SQL? If you the verbiage and the terms, if it is very similar to your domain knowledge or your domain experience, that will help user to work in a much easier fashion, right? Do you agree with me? Hello.
I didn't get what you said.
So I
Hello?
was, uh, if you are working with any system, if the query is more specific to your word or the terms what you
Hello?
use in your day-to-day
Can
life,
you hear me now?
I can hear you. Can you hear me now?
Yes, I can hear you now.
Okay. So what I was saying now is, like, let's say you are a healthcare professional. I'm just assuming that you are a healthcare professional. If your query or the language what you're gonna interact with the Elasticsearch, if it is much similar to your term what you use in your day-to-day life, then writing a query becomes much simpler, right? Do you agree with me?
Yes.
So that is what the DSL tends to focus on. So it will try to make sure that user can write queries so easily. That's the main intention. Coming back, the general query in the system comes from the two different parts. One is the queries, and another is called a filters. Okay. Let us understand what is query on the first hand, and let's understand what is a filter. By chance, do you have any knowledge on SQL? A little bit of understanding on SQL by chance, Victoria? Any chance?
If I understand queries,
Yeah, SQL, structured query language, the database, the
yes,
MySQL.
I just started
Sorry?
learning SQL.
Okay,
I only
okay, no
started learning
problem.
SQL recently, so I just have like
Okay.
basic idea.
Okay, great. So let me make in a simple terms. The filters are the exact match. If you have a Excel, if you go and filter saying that age equal to or age is greater than 15, we apply the filters in the Excel sheet, right? The general filters what we apply on day-to-day life in the Excel spreadsheet. That is the actual filter. So the filter will try to emphasize whether it matches the given condition or not. It will look for exact values. What you see is the exact value. If it matches the exact value, then it proceeds. Then all the results are cached. You understand what is a cache, right?
Yes, like the
And it's
temporary storage.
Yes, right. So, and it's much faster. So, the filter component of Elasticsearch works on this fashion. It is faster and is cacheable, and it can look for exact values and works on the Boolean mode, yes or no, true or false condition. If you come for the querying part, now the emphasis comes here. Results are not cached, and it's slower, and it's a full text search. So there is a two kind of fields in Elasticsearch. Just to understand the holistic level, there are like two important kind of text fields available in Elasticsearch. One is the keyword, and one is the text. You read about the text and keyword anywhere, Victoria, before?
I
Hello.
think so, yes.
Yes,
Hello?
great. Yeah, yeah. I'll just give a small intro about the text and keyword. I'll just open the part for the text and for the keyword. Can you read out what is they have mentioned here, Victoria, for the text part?
A field to index full text value, such as the body of an email.
Can you
Sprint
understand something?
analyze.
Yeah, yeah. Proceed, proceed. I'll explain you once you're done with it.
Okay. Okay. So we are saying that text are not used for sorting. Like you can do a full text search, you can use it for searching, but it's not used for aggregation. Okay, I kind of understand it.
Yeah. So the example what I like to present here is if you are using the Google Drive or Gmail, if you want to search any specific mail from your inbox, which we tend to do, right? We might have sent a mail some time back. We may not know entirely the content by heart, but we know just pieces, bit and pieces of the content in the email. We go to the Gmail box and we give the query and we start collecting some information, right? That's what people do it, right? So you supply some small information for the whole corpus. From that, system can infer or it can search and provide you the result. You understand, right? That is what the text field does for you. Are you clear till this point?
Can you please repeat it again?
Sure. Let me just give you the demo. That would be better. I'm just opening my Gmail box, okay? Okay. I should open the other account. Okay. I'm just looking the keyword here.
Yes.
Can you read it down?
The filter index structured content such as email addresses are typically used for filtering for sorting applications. Yes, fields are only searchable by their exact value. Okay. I think at the initial stage, when we started, as an after indexing a document, it will ask you for like the data types you want to use as keyword, right?
Yes, right.
I think we did that at the initial stage.
So what they are trying to compare here is if you have a string in your document or any content, what you're going to index into Elasticsearch. Now string can either take a text field or it can take a keyword. If it have specifies a keyword, you have to give the exact match. Understand? I'm just using the word called exact match. Only if you provide the exact match, it can retrieve the content for you. If there is no exact match, then it is hard for you to, it is not allowed. That's kind of completely banned. You have to give the exact match to get the content. But if you see the other way, like the tag, what is it called, the text part, that text field, even if you supply the partial keyword in the document, it is searchable. That is the whole idea here. I hope you are clear, right? If you want to
Yes.
search the content in a document, then you have to use the word called text. A text keyword, you have to use it. If you want to go for the exact match, then you may have to choose with the keyword. Can you see the examples here, right? The status code, the zip code, the tags, those are the keyword fields what they are mentioning in the document. If you look for the text data type, the very thing they say is a body of an email, because we just have to always we are searching for we just know some content in the body of the email we are trying to search. Similarly, if you are opening up any Amazon or a Flipkart or any product recommend product site, you provide with the product description. You just say that black color T-shirt or black color shirt. That's the item you provide. The shirt might be had a name called polo or crocodile, but if you are trying to use a word called black shirt, now it goes and searches in the product description and returns back the result. I hope you are clear with the example, right?
Yes.
Great. That's what the queries works on the text field, Victoria, while the filters works on the keyword. That's the whole idea. Hope you are clear till this point, right?
Yes.
Perfect. Now the first and foremost query what people used to do is the get underscore search. Now let me spin up the instance. Okay, it started. Now let's go to the browser. Okay, I'm just opening the dev tools. Let's take the example of mapping ELK. That's the traditional one which we know. Get mapping.elk. Can you see what is displayed on the right hand side? Can you see here, Victoria?
Yes, integer text, float text, integer.
Float.
Yeah.
You see the different the types what we have mentioned here, right? Everything is a text or a float or whatever we call it. It comes over here. Okay. So the first and foremost query what we tend to do is we just use a word called underscore search, which are doing for a very long time. On doing this, if you use the plain underscore search, you remember, right? I said the default number of document displayed to the user on giving underscore search is 10. You remember the first class I mentioned, right? Only the
Yes.
top 10 results, not even top, the 10 results will be displayed to the user. If you want more record, the option would be like adding the field call size or the column call size. If I just specify 20, then 20 records return back to the user. See, if I want to retrieve 100 documents, so basically, I'm able to retrieve the 100 number of documents what I like to retrieve back from the system by using your using the field called size. You are clear to this point, right? That is the
Yes.
first one. And if you carefully notice, I'll just go to the top. If you carefully notice, can you see something called score here?
Yes.
Everywhere if you see the score, it everywhere it comes around 1.0 constantly
What does
because
it
the
mean?
yeah, that's a good question. What is score really meant here? The score is some kind of a number which will indicate that how much this document is relevant for you. Let's do by this way. If I search with the Nigeria and if I say something called food, I'm just using the same word. I have been displayed with this website, Africa Tourism Travel Log 23 Nigerian food. So it gives me like a Wikipedia comes in this part. If you do the search in your computer, it is there's a high chance or there's a chance that you can have a different result. Do you agree with me? Your result and my results will be always different. Do you agree on that point?
Yes.
Can you say why it is different for you and me? Because I am searching the word called Nigeria food. Why you are getting a different result and why I'm getting a different result? Have you ever thought why is it so?
I think they probably use a lot of information to display any information that is relevant to you.
Yeah, now you used a word called which is relevant for me. You came with the word called relevant for me, right? So the system uses lot of data to understand or give a feedback which will be more relevant for me or you. So basically, try to give a personalized recommendation to the user. Do you agree with that? How that's what the Google
Yes.
really works in general.
Yes.
So it understands a lot of data and decides like what will be more appropriate for you. That is the big picture here. Coming back to the story, if you see something called score equal to 1, if it says that all the document are given equal weightage, means indicates that this document is not inferior to the document id 2, or document id 2 is not inferior to document id 1. All the document has the same ranking feature. Okay, that is the whole notion. We will understand one by one. But till now you understood what is the concept revolves around, right?
Yes.
Perfect. The second part, what we're gonna do is to understand something called match field. Okay, if you carefully notice, I just use the same word, but I'm just using the type called match with the title and my content. Let me go through this part in the Kibana here. I'm just using the word called get mapping.elk stat underscore search query match, and it requests me to provide the user field of my choice. Now the field of my choice is the name. Okay, I'm just want to select the name. I'm providing the name over here. I'm just selecting the word called Harris, the partial word. On doing that, it says that it returned the document which has like a count of 15. Okay, it returned the document which has the condition word called Harris, not the complete name. You understand? I'm just giving my partial name here. You see the difference here, right? I'm not giving the exact name here. I'm just giving the partial name what I get from the system. Can you see the score here now?
It has changed to 5.7.
5.7. If I go to the second result, still it remains as 5.7. 5.7 and goes on. I think everything. Yeah, can you see here?
It has reduced to 5.1.
Yeah, now score starts to decrease as you go on. If I tend to have a different word, maybe let's say a Henry. If I go with a word called Henry, now my maximum score is like 3.7. My next document is also 3.7. It goes on. And you see here the document score is reduced, right? So it tries to basically replicates what Google search engine does for you. It gives the importance for each word in a document based on an algorithm called TF-IDF. You remember the algorithm I used to mention in the first class, right? So now this algorithm will give you a score. Based on that score, your result would be sorted and provided to the user. That's the bigger idea here. Can you see here, right? If you just open and understand what is being written here, in information retrieval, TF-IDF algorithm, the short for term frequency, inverse document frequency, is a numerical statistic that intend to reflect how important a word to a document in a collection of corpus. When you do a search, it basically decides that how much important the document for the given space, and it is often referred as a weighting factor in a searches like text mining and user modeling. So like what Google does in a very fundamental ways, kind of using the TF-IDF to get the part. And you see here, right, one of the simplest ranking functions is computer using TF-IDF for each query, and more complicated ranking are a variant of the simple model. So you understand, right, what is happening now. Can you see the word called relevance here? The variation
Yes.
of TF is often used in search engine as a central tool in scoring. The word scoring is being used, and ranking is also used for a given user query. The user query what we gave earlier is the term called Henry, right? That's a query what we are searching in a system, and it says that a given query and its various subject field including the classification. It decides, okay, based on the number it gives you some score. From that score your document is being ranked order. If this higher rank, then you are returned back to the user with the result. That's the key idea here. Hope you are clear to this point, right?
Yes.
Great. That's the match query. Now you understood what is a match query would look like. And there is something called match all. Without any filter condition, you are trying to search for the all the document. Again, if you notice here, all the document would be given a equal weightage here in the match all clause. Query match all. On doing this, you see here, right, all the document will be given an equal score equal to 1111. All the document would be given an equal score. It's something like regular to underscore search, nothing fancy here. The next query what we'll be doing is on the match phrase. Let me just pull up the match phrase here. Get slash mapping.elk underscore search query. You see something called match phrase, right? Now I am gonna
Yes.
search with the phrase word. Now I'm using the same word called name. Now I'm just searching for the document which matches this phrase, the two words altogether. Still, I'm not giving the complete one, but I'm giving a phrase altogether. Match phrase. Is the field name correct? Okay. The name should be a caps here. Do you see here, right? Now it is returns a rank by giving the maximum score is level 11.5.93 and returns a document which matches the condition. So it has like four different matches for the given query, like ALDA ACLM. So it returns me the result saying that it all matches the thing. So now we are giving like two words which combines to from the phrase over here. That's the match phrase. Now the third part is get mapping lk underscore search query match paste prefix. Now the match paste prefix will try to emphasize that if you give some prefix to your search, like you should have the content in before. That's the key idea here. Basically, if you just give the hint saying that let's search with the word called Nazir. Now the document consists of the word called Nazir is being displayed back to the user. Can you see here, right? If let's search for the Misters. Now it matches like 387 document which has the word called Misters and returns you the result back. Like what are the document it matches with the word called Misters here. And if you let's say if you want to search with the word called maybe let's pick it up with the dot or a Carolyn or let's use the word called based from. So now I'm just giving the prefix part. So whatever you should have the prefix content than the suffix part. Like what I'm mentioning here is now if you just say based on Mr. It should be in the prefix part. Only if the prefix matches, the second part would be retrieved back. Even if the order is different, if I just interchange this order, now this doesn't work because you have mentioned that the prefix this works by the prefix part. You understand, right? How the match-based prefix works. Now the prefix will try to emphasize saying that ordering is very important. Hope you are clear to this point, right? Early in this case,
Yes.
if you interchange and run, it will work. If I go and change on the match phrase, now it returns me the three result. Even if I rerun and run it, let's see what happens now. Now the match phrase doesn't match a given condition, but again, if I just give the word called asim or adial, it is able to still return the result. The prefix will try to emphasize a condition, or you can use some partial word. Let's say the base from. See, I'm able to give a partial word here. I'm not even giving a complete word. I'm just giving partial word. I'm just keep on reducing. I'm just getting byst. Now you see it right. See here, right? I'm able to get a smaller subset. I can give like hen. Now, what are the name it match with the HEN just matched here? Can you see here, right? Henry, Henwick. Can you understand, right? How is that? How it understand how it relates? Hope you're clear to this point, right?
Yes.
Great. So this is with the scoring part. So that's the first level. That's the part like the algorithm they are saying here, how the algorithm works. I'll just explain the algorithm in a simpler fashion. Maybe I just like pulled out. Yeah. Here when they mentioned right the full text search query, match query, multi-match, common query, simple query. The thing what we have to look here is on this part, the different term level queries. Term, terms, range, match, prefix, these are the different variants what you see in the system. Can you see the term query here, right? If you want to search in a specific field or only a single field, you can use something called term. If you want to search a given query in a multiple field, then you can provide the terms, which is the plural part of the term here. Just add the S here. If you let's say if you want to search for a product which contains a black shirt, now it should search on the product name as well as in the product description. So that during that time you will use something called term query on that. And what about the range query? If you are searching for the ages like age greater than 10 and less than 40, you are doing a range comparison, right? So for that range comparison, you will use the range query here. The second part of the exist part, it whether checks whether the document is exist in the system or not. The prefix part, like what is like we are saw the prefix query, right? How the document should be prefixed in the wildcard. Even if I just go and give the star, it should work out of the box. If I just say Henry star, let's see how it works. See now it can start to understand the star pattern. Look, while now it can able to see the Henry and followed by star. It starts to does the regular expression scan for you. Hope you're clear to this point, right?
So if you use star, that is acting like the wildcard search. It will bring up every word that
Yes.
starts with HEN, right?
Yes, you're right. That's a wildcard search. You're right. Clear till this point, Victoria here, right?
Yes.
There is also a regex query. Wildcard will support like one or two normal operator. But if you go for regex query, now you can define like complex use case on the regex part. Still, you can go as complex as possible. That's on the regex part. Have you worked with regex regular expression before, Victoria?
No.
Okay. This is like a glorified or the more detailed way of the wildcard search. It's also a wildcard search, but you can do much more than in the regex query. That's the part I'm coming to emphasize here. Clear, right?
He said it will do much more than wildcard.
Yes, you are true. Yes. I'll just show you some example how the regular expression query really works in. You will be surprised to see that how complex or how simple you can make your life much more simpler way. If I have a name, Hari Ganesh. So can you see here, right? In this document, I have a two email IDs here. One is my email ID and one is something like very similar to yours. And I have free flow text and I have a number, okay? If I want to match all the digits over here, can you guess what could be the way to extract all the numbers from the given text? Can you think what can be done?
You call for like integers or something.
You see what I'm trying to do? It might sound like Greek and Latin, but it's way simpler. I'm using something called backslash D and using a plus. So, can you see here, right? Now my numbers are matched over here.
Okay.
Only my numbers are matched. If I want to match the only the email ID, I don't want to match these two content. I'm using slash W, which is the word, and using the at operator. slash w slash dot. Can you see what is happening now here, right?
Yes.
So I'm able to, from a given corpus, I'm still effectively able to retrieve only email ID from the document. I'm not searching the other space. My email ID is exactly pulled out from the document. Can you see the beauty here, right? I didn't write any complex code to write the extract the email. I wrote simple code, simple regular expression pattern which can extract the content from the system. You're able to appreciate the power of the regular expression, right? That's what I said. It is much more powerful. If you go and type slash star, now all the that's what you do it in the regular expression, right? If I just say Victoria star, if I use Victoria star or dot star, can you see here, right? With this entity, I'm able to search the entire email ID from your corpus. Can you see here, right? How it's done?
Yes.
Hope you can understand how it, why I said it's much more powerful, right?
Yes. Because it's easier to search.
Exactly. You just give a try on learning regex regular expression, Victoria. It will be much powerful for your day-to-day activity. You will be surprised to see that how automatically or how effectively you can do your job if you know the regular expression. It's more powerful than what we think. Okay.
Okay.